Yo, hey, what's up? More on the chain rule. Right, I'm gonna kind of clarify some things I might have missed in the last video. Then we're gonna talk about how to apply the chain rule with the product and quotient rule, because it happens a lot. Sometimes it gets pretty tricky, pretty messy, overall rather difficult. The calculus part isn't that difficult, but the sometimes algebra, the moving variables around can be, right? Especially when you're trying to solve or plug in values. So let's say you have a function, y, which is equal to f of, hear me out, u, okay? And that's equal to a, just equal to some stuff. Goose, stop that. Okay, right? Now y prime is gonna equal f prime of u. I wrote x, didn't I? Gonna equal f prime of u. You know what, here, let's just make this x, so that's less confusing. F of x and f prime of x. Okay, now, with the chain rule, this is kind of another textbook definition thing. What we've seen is that this f prime of x is actually going to be equal to, and I'll use dy here because this notation will kind of make sense in a bit, dy with respect to u, right, kind of that other variable, times, and then the chain rule says we're going to take the derivative of u with respect to x, right? Now what that does is that kind of allows us to get those huge stepwise, or not stepwise, composition functions, nested variables, all of that. And what we end up seeing, kind of just like basic algebra, those cancel out, and then you're just going to get dy dx, right? Now the important thing is that this variable here on bottom is going to match your input, right? And u is going to be that substitution, right? So for example, if I have f of x equal to, let's go with 4 times quantity x squared plus 1 cubed, right? Now let's say, hey, u is going to equal x squared plus 1, right? So this is going to be equal to 4u cubed, right? Now if I were to take the derivative of 4u cubed with respect to u, right, we would get what? 12u squared? Okay, but that's a substitution. We have to multiply by this kind of like du dx, right? Let me explain in other words if that doesn't make sense, right? So, yes, we have this 4u cubed, and then you take the derivative of that, you get 12 times u, but I'll expand u into x squared plus 1 cubed. And now that is going to be times the derivative of u with respect to x, right? Times du dx. But this is u. So what we're doing is we're going to derive u with respect to x, this x variable. So we're going to derive the x variables in the u term. Just like if I were to have y equals x, we're going to derive, or if we're finding dy dx, we're going to derive the x terms in the y function. Here, we're deriving the x terms in the u function, right? So it's kind of a two-step process. So the chain rule is going to say, we're going to have to multiply this by whatever the derivative of this u part is, which is going to be just 2x, right? So secretly, we've been doing this whole dy du times du dx thing, always are doing that in calculus. If I were to, and let me erase all this first, take the derivative of, 4x cubed, right? Not u, that's going to be 12. Here, my bad. That's going to say y is equal to 4x cubed. Now y prime, or dy dx, and I'll actually use that dy dx notation here, right, is going to equal 12x squared, right? Doing our normal power rule, but we're technically multiplying this by, this is a bit weird, dx, right? Because we have this chain here, but we're not doing a substitution with that variable u. We're just saying, okay, x equals x. Or you could even say like u equals x. And then you could do the u substitution here, right? That's equal to 12u squared and then times du dx, right? But then that du dx, you take the derivative of u, and that's just equal to 1, right? So you're just really multiplying this by 1, and that's the same thing as if we do dx dx, right? Dx dx, that just cancels out. That's equal to 1, right? So we don't even need to worry about that whole u substitution step, because the derivative of u with respect to x is just going to be 1, right? So unless you kind of have a nested function where you usually have parentheses, or you usually have an exponent outside of those parentheses, you don't really have to do that u substitution if you want to think of the chain rule that way. Chain rule always applies. We've been using chain rule this whole time, and I haven't even told you, because we don't really need to write out times 1 on a lot of our functions. But from now on, we're going to be dealing with more complicated functions, usually involving the chain rule, where a chain does not equal just 1, right? And so we'll need to think about that. But again, if you're doing a simple derivative, don't write that times 1. That you don't need to do that. But big takeaway, everything has a chain rule. We don't need to always use that. We always should think about the chain rule. We should always be thinking, hey, do I need to use a chain rule here? Am I forgetting something? If you're forgetting something, probably the chain rule, right? Okay, now let's look at product rule with this example. Okay, I'm going to say, let f of x, bear with me here, I'm going to make this up on the spot. Let's go with 2 times x cubed plus 2 squared times, here's a good one, sine of x, right? We know how to do that. We know how to derive this, and we know how to derive this. So let's begin with the product rule. F prime of x, we're going to need to use a product here because we've got these kind of multiplied functions. Sine of x, can't combine that with 2 times quantity x cubed plus 2 squared, right? Or quantity squared. So we're going to use our product rule. You won't forget it. Left d right plus right d left. Left, 2 times x cubed plus 2 squared. Okay, d right, cosine of x. Right, derivative of sine is cosine. Plus right, sine of x. D left. Okay, this is where we're going to have to use our chain rule. And the chain rule is always going to be your kind of like last step. You're going to do the product rule first, and you're going to do the chain rule within your product rule. Same thing applies with the quotient rule. Okay, now we're just looking at this part here, d left. That's going to equal, I'll use a big parenthesis here, 4 quantity x cubed plus 2 to the first power, because we subtracted 1 from that power, times the chain, which is going to be 3x squared. You do the chain rule within the product rule. That's our derivative. I'm not going to simplify it. If you want to try, cool, go ahead. You could probably factor this in, distribute this, or my bad, distribute both of these. I don't think there are any common terms, so yeah, that's really it. That's a derivative using a product rule and a chain rule, right? Now let's do a quotient rule. Quotient rule gets a little bit more messy, generally. And again, if you can turn a quotient into a product by like flipping something up, bringing it to the negative power, generally things are easier, right? Like I don't want to take the derivative of 1 over x with the quotient rule. That's difficult and tedious, when I could just take the derivative of x to the negative 1 with the power rule, right? Both, the same thing if you use the quotient rule, it works. You can do the quotient rule. Derivative of 1 is 0, so a lot of that stuff cancels out. Okay, now let's say g of x is going to be equal to, okay, let's go with something more complicated on the bottom. So how about square root of x over 4x cubed minus 2. No, not minus 2. Minus 3. So we can't factor anything out. And all of that to the third power. That is to the third power, by the way, if you can't see that. Okay, I'm going to rewrite this as x to the 1/2 over 4x cubed minus 3 cubed. And looking way back to Pascal's triangle, you could expand that, and then you wouldn't have to use a chain rule, but the chain rule is it's an even further shortcut than Pascal's triangle, right? And you'll see that here. I'll start all the way over here. I'm gonna need some space for this one. G prime of x. Okay, G prime of x equals, you'll never forget it, low d high minus high d low, draw the line, square the low. Okay, low, that is 4x cubed minus 3 quantity cubed times d high. Okay, x to the 1/2 power, that's going to be times 1/2 x to the negative 1/2. And it's an exponential there to the negative 1/2 power. Okay, minus high x to the 1/2 power times d low. Okay, we're gonna use our chain rule here. I'll use a bracket this time. Okay, it's going to be 3 times 4x cubed minus 3 squared, subtracting 1 from that power still, okay, times the chain. The chain here is going to be 12x squared. And that's our chain rule right there. And the derivative of our low term. Now all over square the low. That's pretty simple. 4x cubed minus 3. Okay, to the 3rd power. Now all of that squared. Now, when you take quantity that's raised to a power, raised to another power, right? In this case, we have this whole cubed quantity squared. You just multiply those, right? Power to a power, multiply them. And so that's what I'm going to do here. Oh, forgot to erase that 3. And that's going to be here 6. Okay, and that's it. That is a quotient rule. You can simplify this for sure. Oh boy, you can bring this term down. You can factor out some things. Generally, when you're factoring things out of a huge numerator like this, like let's say I wanted to get this kind of x to the 1/2 term out, you're going to want to pull out the least term, if that makes sense. So what I would do is I'd factor out like x to the negative 1/2, and that'd give me, okay, dot, 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 minus, okay, and then this, if you pull negative 1/2 out of that, you actually are left with x to the 1st power, right? Because you're doing 1/2 minus negative 1/2, because remember when you divide out that fraction, when you kind of factor it out, you're actually subtracting those exponents, right? And so that'd just be left as x. And so you could factor that. You could simplify this, again, distributing. You might be able to combine some of that up there up top, but for now I'm just gonna leave it at that. I don't want this video to be any longer than it has to be. Big takeaways. Quotient rule and product rule come first. You do the chain rule within those, okay? And then kind of this weird textbook definition that if this makes sense to you, good. If not, that's okay. I'll write it out because sometimes it's cool to think about this is your chain rule here. You're taking the derivative first of the y terms, but you're deriving those u terms, right? So you're deriving like you're deriving this as if there was no kind of expansion there. Like let's say if u was equal to 12x to the 4th power minus 3x, right? You're just ignoring all of that. You're just going to derive this u term as normal, and then you're going to look at this kind of expanded part, derive the u terms now with respect to x, right? It's like if we were to derive y equals 12x to the 4th power minus 3x. Ooh, I'm going off the page. There you go, you can see that. Perfect. So that's a big takeaway. If you like that textbook definition, cool. If not, then you can just think about doing the chain rule, like going from outside to inside. That's how I like to think about it. Anyways, thank you for learning with me today, class. I know we're getting into some tough examples, but really the calculus stopped when we finished this chain rule. If you want to simplify anything else past that, that's just all algebra. So see you later, class. Goodbye.